There is a start, yes. You've got carbon. Carbon attracts a proton, and then there are loads of other networks as well. So the net result is the conversion of hydrogen into helium.
So this is the ultimate death of a star, as it uses as fuel, is it?
Yes.
In a coffee cup.
In a coffee cup. Well. Did space and time arise out of an infinity? It assumes that there's an infinity to begin with, and that's not obvious to me.
Is infinity linked to the very starting conditions or not?
If you divide a number by 0, the result mathematically is infinity.
How is it infinity if you're not dividing it by anything? Do you not end up at 1?
No, you end up with infinity. 1 by 1, you get 1.
1, okay.
If you get 1 by a half, you get 2. If you get 1 by a quarter,
right.
you get 4. So the smaller the number, the larger the result. 0 goes into 1 an infinite number of times. Talk about a black hole being a singularity. All of the mass of a star or a galaxy or whatever is concentrated in a single point. Then the density becomes infinite. And that's when physics becomes interesting. Actually, I don't think there's any evidence that the universe is infinite.
Do many people think that it is infinite, or do they think it's finite?
I don't know. What do you think?
It could be finite in the sense that you could have the property that if you keep going in the same direction, you end up back where you started.
How would you end up back where you start?
If you walk around this universe, where do you end up? Back where you started.
How would you test that?
So long as you can measure the total density of material in the universe, including dark matter and all of the matter that exists. I don't know what effect dark energy has on the gravitational field, but dark energy affects whether the universe is closed or not, because it tells us how the expansion is being accelerated at the moment. The universe can't be infinite if it started as a finite Big Bang. It doesn't make sense. I think infinites are out. What did space expand from? What is space expanding into?
I suppose it's that boundary question, is it?
I mean, I think it's a very good question. We talk about balloons and explaining. You see the balloon expanding around you, and then you can ask, what's this expanding into? Oh, there's a third dimension. It's called the room, and it's full of air. We're expanding into the air, but that's not part of our universe. That's an untestable hypothesis that there is a room into which the universe is expanding. But there's no evidence there's any need for that. So the universe is an entity in itself. Yeah, but it's a big question.
You would make a visual picture for yourself when you're thinking about something?
Oh, absolutely.
Yeah.
Absolutely.
One of the appeals of stars to me is that it's more easily visualised.
I mean, I like to try to visualise the Big Bang.
It's not easy to visualise, you just can't see anything.
Well, everything is ionised, so you're in this ball of glowing gas. You can't see through it. First galaxies only form after combination. You have the question of why was there symmetry breaking? Basic theory is that you have equal amounts of matter and antimatter. There was a very small imbalance introduced. How did that happen? But I can't visualise any of that yet.
The specific questions I was interested in asking you were about the Great Bear.
Right.
I did this chart.
Right.
The ones I've abstract are ones I think that need included.
You've got a choice as to whether you use just the plough or the whole thing. But you've also got a choice of where are you standing? Are you looking up at it? Where's the point at which you recognise it? It's like when you lie on a sunny day and you watch the clouds running past, and that's a castle and that's a dragon. That's how the ancients started to look at the sky. In order to remember it, they told stories, and they connected the stars in the sky with the stories that they told. So what I was actually looking at was, first of all, what the technical challenges were, and if you only did alpha to zeta, your distances aren't that big, around 100 light years. If I were you, I would put them in order of brightness. I'd just have a column for, and go alpha, beta, gamma, delta, and then anything else.
So I was trying to find their absolute magnitudes as opposed to their apparent magnitudes. So I put A here to denote absolute. Should I actually represent something of that, because that says something about them spatially?
The way this would work, Kappa Ursa Majoris, what you see is that its apparent magnitude is 4. And because it's Kappa, it's about your 8th brightest.
Which one is Kappa? Yeah, it's the knee joint here, is it?
That's Kappa down there.
Yeah, the toes.
Now that's quite faint.
Mm-hmm.
However, it's the brightest star in your list. It's a long way away, but it is a early type. What does it say? B minus absolute magnitude minus 1.4. You need to go to the catalogues. Ultimately, catalogue of bright stars.
Catalogue of bright stars.
Don't go anywhere near this without a health warning and a life jacket.
Really?
It's got 9,000 stars in it, which is not that many.
That's what I've been trying to do with the height thing. Measuring these relative distances to each other, that we see how far apart they're spaced, but of course I know some are much nearer and some are much further. So if I get that to 3.5 metres high, it's the one that's like 350 something light years away.
Yeah.
If I have a lower object that's a metre off the ground, it's 100 light years away. Somebody can walk in and around through this arrangement.
Right, but then they won't actually see the constellation. If your objects are physically in the correct positions with respect to one another, it's true that you can walk through amongst them, but there is also a place somewhere at which you would be able to see them as we see them now. Just mark these out on the floor, like this. Now, if they were all laid out on the floor, that's actually straightforward technically. Now, the other way would be to rotate the whole thing.
But they're projected from something that's perpendicular to the plane you're on.
But if you actually look at them from this angle, what you will see is the shape of that on the back wall.
Do you think I should map it perpendicular?
I don't know. I'm thinking from the point of view of the scientist who wants to explain things, and I want to try to give people the aha moment. I actually loved the idea. One of my first conferences I went to, I saw that, not as a picture, I saw it as a model, and they showed the distances of all of the nearest stars within a certain number of light years. And I thought, that's fantastic. I would like, if I had the space and the facility to do it, that you could walk along a walkway in the dark and you could see the stars and each of them glowed. It's coded in this spectral type. A B minus V of 0 is white. A negative number is blue. A -1 would be a very red star. It is just a measure of the colour. It's a measure of the brightness in blue light minus the brightness in visual light. The more negative it is in blue light, and the more positive, the brighter it is in visual light. And that is just what colour is.
With chalks I can make colours.
Yeah, so let's take this one up here. Omicron, Ursa Majoris.
Do you know what colour it is?
Yellow. Unless you know what both stars are. Normally, if it says G, then yellow is fine. You've got two yellows. The fainter component may be more difficult to identify. Good. I wonder if there's anything else that's interesting in Ursa Majoris.
Am I right in thinking that the deep field image that the Hubble telescope took Did it take it from a region of sky within that constellation?
Yeah, it is in Ursa Major. In that case, you've got to put the deep field. I talk about the deep field, and I use the Hubble deep field to illustrate the evolution of the universe, because in that you actually look back in time and you can take slices of time in that image